Welcome back to our first video after our mid-unit quiz, for lack of a better phrase. We are entering the wonderful world that is inequalities, once again reinforcing a lot of the concepts that we've talked about in your earlier math classes, such as Algebra 1 and Algebra 2. But for today's topic, we have inequalities, and we'll probably wind up touching upon some inequalities you may have never worked with before, and that's totally fine. We're learning to solve linear and nonlinear inequalities so I can identify an inequality and a description that represent the constraints and possible solutions in a situation. Merely being a robot and methodically being able to solve inequalities is not our goal here. Our goal here is to kind of determine how are these inequalities applicable to our lives and how we can recognize and analyze various situations. I'll know I've got it when I can describe in writing how to solve nonlinear inequalities, because let's face it, our world is a scary place and things don't necessarily work out like a linear equation. So let's begin. An inequality looks very much like an equation. To solve an inequality that contains a variable means to find all values of the variable that make the inequality true. Unlike an equation, an inequality generally has infinite solutions which form an interval or a union of intervals, and we'll get into that a little bit towards the end of this video. We would say that an inequality is said to be linear. Term is constant or a multiple of the variable. So I'd like for you to kind of work remotely with your peers and recall this process of how to solve an inequality. Think through all of your workflows, kind of checks and balances, things that we need to be mindful of as we proceed through an inequality. And let's see if we can come up with a nice group consensus before proceeding into our next slide. So these are inequalities that you should be quite familiar with. In the case of some inequality like B, this would be considered a compound inequality. And the way I like to kind of think of these is, once again, wish I was in person, but if you kind of covered up this component, right, what would be our first step in solving this inequality, and vice versa? If we covered up the right bound of the inequality, what would be our first step solving this inequality? They would have the identical step, so we can kind of kill two birds with one stone, and we would want to add 2 in all sections of the inequality. Therefore, we have a remaining statement of 6 is less than or equal to. If you press the less than equal to sign, less than the equal button, that symbol will appear. Right? And you can probably from this point take it from there. So please make your way through A and B, because this is where we're going to be doing a bulk of our work. I'm not going to sit here and read the slide. You could pause the video and read it for yourself, but nonlinear inequalities make things so much more tricky because we're dealing with products and we're dealing with quotients. And the reason why that is such a big deal is because if a product or a quotient has an even number of negative factors, then its value is positive. It's like our previous videos have shown, right? If we multiply or divide two positive or two negative numbers, we'll have a positive output. And vice versa. Product or quotient that's an odd number of negative factors, then its value is negative. So in other words, we're going to go beyond just replicating processes and embrace our intuition, kind of tease out what is explicitly happening Therefore, we wind up making the right decision. Oop, that's awkward. Check 0.5. Okay, so we still treat this the way we would a normal solution. But in this instance, we want to first collect all of our terms to the same side because we are dealing with a quadratic inequality. So I'm going to rewrite everything in this manner. And then I could, if I wanted to, factor this expression. So this expression is going to factor as x 11, x plus 4 greater than or equal to 0. And quite typically, right, if this were an equation, we would say that x is equivalent to 11 and negative 4. And we're more or less doing the same. However, as was stated 2 or 3 slides ago, inequalities are going to create intervals. Still working on the whole straight line thing. Let me see if I can, let me do one more shot. There's a straight line button. Right, so in this instance, okay, I want to create intervals using the points 11 and negative 4. And based on this notation, select test points in each interval and determine if their outputs are indeed less than 0. If they are, that is the interval where our solutions lie. If they are not, well, those intervals do not apply. So in this case, I will pick a value like negative 10. Now the good thing is we don't really care what the number is. We just care about the sign. So if we substitute accordingly, negative 10 minus 11 will yield a negative, and negative 10 plus 4 will yield a positive. Just kidding. That will yield another negative. Jumping the gun here. So our final output is positive. So this interval does not work for this particular solution. Okay. In the event we select our middle interval, I always like to pick the value 0 because we'll get a negative times a positive, and that output is negative. So this interval here works. These solutions apply. And if I picked a value here, I mean, for all intents and purposes, why not? Let's use 44. I'll get 2 positive values, which will have a positive output. So as we can see, the only interval that contains solutions would be negative 4 to use brackets. There we go. The bracket buttons are located next to the letter P. Okay. How do we determine the whether it's brackets, whether it's curly braces, so on and so forth? We could simply test those particular point values. So with negative 4, if I substitute it into my inequality, I'll have a negative value times 0, which will yield 0, which is less than or equal to 0. And same will hold true with the number 11. So this is why I want to use brackets rather than parentheses, because those solutions can be included in our final answer. So I ask that you calmly make your way through this very methodical, tedious process for both B and C. possibly rewatch what I had just done. It should alleviate. And words of wisdom say to always check the endpoints of the solution set to see whether or not they satisfy the original inequality. And had we substituted both -4 and 11 into our inequality, we would see that we do get equivalent expressions. All right, so for absolute value inequalities, it might have been some time, but they're a little bit more straightforward than, I would say, a nonlinear or a quadratic inequality. So in this event, the absolute value of x is less than c means that x will reside between both the positive and the negative value of the number specified. On a graph, if you've forgotten, anytime we have less than or greater than, right, but no equal to, let's say we designate this as 0. Right, we would use a open circle. And this compound inequality means that the values of x lie in between these two values. So please take a moment here to complete our table and sketch the corresponding graphs to represent absolute value inequalities. Okay. Now be very careful here, because notice we have less than, the absolute value is less than, and then the absolute value is greater than. They're going to yield two different styles of inequalities. We'll have a compound inequality when it is less than, and when it's greater than, we'll have two separate situations. So in the case of part B, because those usually tend to get a little wonky, we'll have 3x minus 2. We'll have the inequality as it is. We'll have the absolute value in the opposite. So rather than greater, it will be less than or equal to the negative value. So kind of this idea of like we're dividing by a -1 with whatever value is on the opposite side of the absolute value, and then we would correspondingly solve these and then graph their solutions. And that's where we will pause before we pick up on a doozy of a lesson in lesson 9. Thanks for coming, and I'll see you in the next video.